Here's where we left off last week. We had a graph that looked something like this, and we wanted to tell if there's a path from Athens to Carthage or from Athens to Budapest. And so we're going to devise a graph connectedness algorithm, an algorithm that crawls our graph and figures out which parts of it are connected. And then it will be very easy to tell if you can get from one city to another through this graph. So I'm going to introduce a little notation here. We're eventually going to assign each node in the graph to be one group or another. And when I do that, I'm just going to color it in like this. That means it's in the yellow group, or I may put it in the purple group. So let's get started. Oh, one more bit of notation. I'm gonna circle the current node that we're looking at in green, just so that we can keep track of which node we're looking at right now. So the first step in the algorithm, step 1, is we're gonna pick an unseen node. Okay. And we haven't looked at any of these nodes. When I say unseen, I mean it's a node that we haven't considered yet in our algorithm. We haven't considered any of them. So we're just going to arbitrarily pick this one. Doesn't really matter which one is one, as long as it's one that we haven't picked yet. So we've done that. Let's move on to step 2. And that is to mark it as being in a group. So we're going to start with the yellow group. I'm going to mark it as being in that yellow group. Easy. When we add it to a group, we're going to consider it as we have looked at the node, we have seen the node, it's seen, and we won't consider it anymore. So let's see, mark. We mark it as being part of a group. And then step 3 is we follow its edges. Follow edges. Any edges that are coming out of this node, we'll follow them and see where they go. In this case, we're going to follow this edge right here to this new node. So now it is our current node. I'm going to circle it in green. When we get to that point, we go back to step 2. And we continue the algorithm from there. We mark it as part of our group, so I'm coloring it in yellow. And then we follow the edges. Now here is our current node. We mark it as part of the group. And now we have no more nodes left. We have no more edges left to follow. So I'm going to put step 4 here. Is to increase the group. Or we get a new group, which is going to be our purple color. And then after we have a new group, we go back to step 1. So step 1 is to pick an unseen node. And since these 3 nodes already have groups, we're not going to pick any of them because we've seen them, we've considered them. So let's pick this one. Again, arbitrarily, it doesn't matter which one as long as it's one we haven't seen yet. So we're going to continue step 2 of our algorithm. We mark it as being part of our group. We have a new group now. It's the purple group. And then we follow edges. Now the problem is here we have 3 edges that we can follow. Which one do we follow? Well, we're actually going to keep a list of all nodes that are possible to go to from this node. So I'm going to circle this one because we're going to go to this one first, but then we're going to remember these 2 other nodes. I'm going to circle them in blue because we're going to remember them. We're going to keep a list of them. We're going to return to them later so we don't forget them. Does it matter which one we go to? Actually, it doesn't. The algorithm will turn out the same no matter which node you go to first. So we're just gonna continue to this one because it's there. We mark it as part of our group, and then we follow edges. Here, if we go back, then it's a node we've already seen. So we continue forward, and this blue node becomes a green node. It becomes our current node. Oops, should be green. Green. We mark it as part of our group, and then we have this weird situation where we follow an edge, but it gets us back to a node that we have already seen. So actually we kind of have to add a new step in here, don't we? Step 1.5, and that is ignore seen nodes. If we've seen the node already, we ignore it. We skip it. Okay? So we're not going to do that node because we've seen it already. We're going to come back here and follow the only other edge coming out, which was this blue node that we were going to look at anyway. So this is now our current node, and we mark it as being part of our group. And now every edge coming out from this node points to a node that we've already looked at, has already been colored in with a group. And so there are no blue or green nodes that haven't had a group assigned yet. So we're done with our algorithm. We have established two islands of connectivity. Here's one, and here's the other. So it's really simple now. If we want to determine whether two nodes are connected to each other through the graph, we just say if node A, if that group is equal to node B's group, and I guess I should use double equals here since we're doing an equivalence, not an assignment, then there exists a path through the graph from node A to node B. Otherwise, there is no path. So let's go to the code and we'll see this in action. Okay, so here we are. I want to bring a few things to your attention before we get started. First of all, that I made these type defs. The type def is like an alias. I'm saying whenever I say edge t or node t, what I really mean is integer. Treat it like an integer, except that edge t's and node t's are not compatible with each other. Edges and nodes are not the same object, and hopefully this will help our compiler spit us out some errors if we try to do something silly like assign a node to an edge. So I did that, and I also made a few helper functions like follow edge, which will hopefully clear up the graph and make things a little bit easier for us. And so let me boot up the game real quick. I say game, it's not really much of a game, is it? And we can see the graph that I've made here. And I've implemented the algorithm in a special way so that every time I press a button, it takes one step in the algorithm. And we'll go and look at the code for that. Actually, here it is. Okay, I'll set a breakpoint, and we can start stepping through it. The first step is to pick an unseen node. And we're going to do that by just looping through the graph and finding the first unseen node. In this case, it's the first node since we haven't looked at any nodes. So we use that as the current node, and we add it to our list of nodes that we're considering. That was the blue circles during the last section of the video. And then we'll go to the next section of the graph. So green is our current node, whereas blue is our open list of nodes that we're currently considering, and we'll see how that comes into effect later. So then I'm going to hit G again. We pop into the debugger, and we will assign, this is the skip scene step. This is the step that we had to add in there. This will come in more important later. But then we will mark our current group. In this case, I'm using numbers instead of colors for the group because they're easier to compare, but it's the same idea. We mark the current node as being in our current group. And now you can see it's yellow. And now we will go to the follow edges step, all the way down to the follow edges step. What this does is we save whatever node is on the back of our vector, at the end of our vector, and then we pop it off. We don't want it anymore. We've already done everything we need to do with it. But then we look at all the edges of that node, and we follow those edges to see where they point, and they lead us to a new node. And we push all of those new nodes onto the current nodes stack. In this case, there's only one. So now you can see that we followed this edge right here, and we now have a new current node, which is green. So let's continue by pressing G, and we're back to the skip scene step here, which is irrelevant. So I press G again, and we go to the mark group step. So I'm going to, and you can see this has been marked in our group. I'm gonna get rid of this breakpoint for now so that we can go a little bit faster. Now we mark this guy as being in our group, and then we're done. And we have to find a new node somewhere, and there it is. This is now our current node. So we mark it as being in our group, our purple group, since we have a new group now. When we ran out of nodes on the left, we increased our group number, we got a new group, and so now we are purple. And now we get to the interesting part. This is where we followed edges out from this purple node to these three new nodes. One of them is our current node, and the other two are just nodes that we're remembering we're going to consider later. But other than that, the algorithm plays out exactly the way it did in the code. Okay, great. So now we know which cities are in which continents and how we can get units from whether we can get units from one city to another if they are in the same continent. So in the next few videos, I'm going to be looking at some pathfinding algorithms and starting to develop those, how we decide which paths, which edges to take through this graph to get from one node to the other so that you can move your units around. I'll see you then.